Okay, welcome to Concept C. We're going to be looking at what we call acid-base titrations and also learning how to do specific calculations relating to this. So the actual procedure is a controlled process of an acid-base neutralization, which we talked about in the previous concept. This is used to determine the concentration of an unknown acid or base. Now, the actual process or procedure for this, we're going to kind of walk through, and this is what we're going to be doing in a lab at the end of next week. We have a specific volume of unknown that's measured out, and we add an indicator, such as phenolphthalein, that we add to this unknown. And then above it, so this would be our unknown down here with the indicator, and then in our burette, which is this piece of equipment, that's clamped to a stand, we add what we call the standard solution. Now this has to be either an acid or a base of a known molarity, meaning we know that it's 5 molar or we know that it's 1 molar, and what we do is we slowly add it to the unknown. So there's a little stopper down here that we open, and then we slowly add it while swirling the beaker at the bottom, and eventually we're going to see that we have a color change. And when that happens, we're going to then measure the volume of our standard solution from the burette, and using these volumes and the molarity of the standard solution, we can calculate the molarity of the unknown solution. So this would be a great thing where if I go in the back of the closet and I see that I have a bottle of an acid with an unknown concentration, I could use a titration process. Now, one thing that you want to that's going to lead up to how we get our formulas is that our net equation, and this is where we take out the spectator ions or the salt that forms from the neutralization. We just look at the positive hydrogen combined with the negative hydroxide ion and making water. Now, this is a balanced equation. So it's showing us that for every 1 mole of our protons or positive hydrogen ions, we need them in order to neutralize exactly 1 mole of our hydroxide ions. So as we titrate, the moles of our acid have to equal the moles of our base. This gives us the formula that you see and that you should be writing down into the box. Because moles of acid equal moles of base, we can rearrange our molarity calculations and show that the molarity of our acid and the volume of our acid has to be equal to the molarity of our base and volume of our base. So just remember, the capital M is representing molarity, capital V is representing volume. Now, one important part of this is that not all acids and bases are created equal. Some acids give off more or less positive hydrogen ions per every compound, and then some bases give more or less hydroxide ions in every compound, and we have to take this into consideration. So just to kind of show you how this happens is I have 1 molar solution of these 3 acids. However, again, I said they're not all created equal. If I look at 1 molar HCl, for every HCl that breaks apart, I get 1 in return. So for every 1 molar of HCl, I get 1 molar of H+. So if I was doing a calculation with this, that would be my number of hydrogens, just 1. However, with H2SO4, we're going to see that for every 1 H2SO4, I get 2 positive hydrogen ions. So again, this would be where I would have to multiply my molarity and volume of the acid by 2. And finally, H3PO4 is going to give me, for every 1, 3. So please make sure you write this down. These are good examples to have to demonstrate how we're going to change and manipulate our titration equation tomorrow in class. Now this also applies to bases. So I have NaOH and BaOH2, and again I'm going to see that for every 1 molar NaOH I get 2 molar hydroxide ions, and then for every 1 molar solution of BaOH2, so barium hydroxide, I get 2 molar of our hydroxide ions. And again, this kind of goes back to what we did in previous units and also earlier in this unit about looking at how many ions we're putting into solution. So again, just remember that you have to take into account how many positive hydrogen ions and how many hydroxide ions the acid and base release. And we have to use that in our main equation we're going to be using for titration reactions and calculations. All right, well that's it.